Hey guys, we're going to dive in a little bit to continuity. Continuity takes on many forms, and you're going to use the idea of something being continuous. So, the idea is this, is that that's continuous. There's no breaks in it, but as soon as we do something like this, it's no longer continuous, okay? So that's just the basic idea of being continuous. This is continuous this way, but once we go past this point of discontinuity, it's no longer continuous. So we can adjust, disregard this right now, so we can adjust the open intervals to make things continuous. So let's just assume that I've got this graph right here like that. And I've got a break right here and a break right there. And we'll just put this on the x-axis, and I'll call this -2, and I'll call this 3. So the open interval where this is continuous is going to be from -infinity to -2. So it's continuous between those points. It is continuous between these 2 points, and then it is continuous after that. So this is the idea of open interval, and this is continuous, right? So that's the idea. So we can start setting. So if we covered this up, this is not continuous. If I took that and said, okay, what's the open interval for it to be continuous? You're saying that I can only use this, this, and this. So therefore now it's continuous on these intervals. So there's a lot of ways we can manipulate it. So if we look at this, there's 3 steps to prove something is continuous. Number 1, f of a must exist. So what this means is like f of 2, when I plug in 2, I get out 4. That's got to exist. If I plug in 2 and I get undefined, it's useless to us. It's not continuous at all. So we're testing continuity at x equal to a. So we're plugging in whatever a is equal to. So there's 3 steps we have to do. We have to have f of a, it must exist. The limit of f of x as it approaches a must exist, and then answer 1 and answer 2, f of a equals the limit as x approaches a of f of x. They have to be equal to each other, and then we can say f of x is continuous over that interval or over the open interval, or at that point, depends on what we're asking. So let's just look at this one right here. So we're asking, is it continuous at x equals -3? So the first thing we do is we plug in -3. So I got -3 squared minus 9, -3 minus 3. We end up with 3 squared is 9, 0 over -6, it equals 0. So f of 3 equals 0. That's number 1. That's step 1. Step 2, there's 3 steps to this. I need to know if the limit as x approaches a, which is -3, of x squared minus 9, x minus 3. Well, what's our rule? Plug it in. So if we plug it in, what do we get? So we can plug this in, and we get plug it in, we get 0, we get -6, so we end up getting 0 over -6 again, and we get 0. All right, so that's 0. So then my question is, does f of a equal, I'm not going to say f of a, does f of -3 equal the limit of x squared minus 9 over 3 as x approaches -3? Yes, therefore continuous at x equals -3. Okay? So that's kind of the idea of how you tackle these. You could have factored this, it would have still gotten the same answer. So there's always 3 steps right here. Okay, so let's look at this.